Let's look at some of the relationships between trig ratios. Now here's a 90-degree triangle. I'm going to label this. This is our 90-degree angle, and opposite that is our hypotenuse. I'm going to label that C. And I'm going to label this side A and this side B. Now typically we would label this angle capital B because it's opposite side B, and this angle here capital A because that angle is opposite side A. So we know that the sine of angle B here, this is equal to the opposite over hypotenuse, which is B over C. And we know that the cosine of B is the adjacent side over the hypotenuse. And we also know that the tan of B is equal to the opposite side over the adjacent side. Now let's take a look at these for angle A. So sine of angle A is equal to the opposite over the hypotenuse. This is the same thing as the cosine of B. Let's take a look at cos B now, cos A. The cosine of A is equal to the side adjacent over the hypotenuse. This happens to be the same ratio as sine of B. And the last one, tan of A, this is the opposite over adjacent, which is the inverse of tan of B. Now, what else do we know about A? We know that angle A has to equal 90 degrees minus angle B, because all angles in a triangle sum to 180 degrees. We already have one angle that's 90, so A plus B must equal 90 degrees. Now let's write this a slightly different way. So we know that sine B is equal to B over C. This is equal to sine of B, which happens to also equal the cosine of A. And if we write A now as 90 degrees minus B, so now we have sine B is equal to the cosine of 90 minus B. Similarly, the cosine of B, we know that this is equal to A over C. This is equal to the cosine of B, which happens to also equal the sine of A. And again, we're going to write A as 90 degrees minus B. So here, cosine of B is equal to the sine of 90 minus B. Now let's take a look at the tangent. Now, here we know that they are inverses of each other, but also, if we take the sine of B and divide it by the cosine of B, we know the sine of B is B over C, and cosine is A over C. So this becomes B over A, which happens to also be the tan of B. So now we have sine B is equal to the cosine of 90 minus B. Cos B is equal to the sine of 90 minus B. And tan B is equal to sine B over cos B. Let's look at one other ratio here. And to do this, we're going to use the Pythagorean theorem, which we know is a squared plus b squared is equal to c squared. Now, in order to do this, we're going to take a look here at our ratios. We know that sine b is equal to b over c. So if we multiply both sides by c, then we get b is equal to c times sine of b. Similarly, with cosine of b, we know that this is equal to a over c, but if we multiply both sides by c, this would give us a is equal to c times the cosine of b. Let's use these values here and substitute them into this equation. So now we have c times the cos of b squared plus c times the sine of b squared is equal to c squared. And let's distribute these values. So c squared times cos squared b plus c squared times sine squared b is equal to c squared. And you'll notice c squared is common to every term, so I can divide every term by c squared, and that gives us cos squared b plus sine squared b is equal to 1. And that is another one of our relationships. Now, you'll notice if we take this formula here, I'm just going to switch these two, which is fine. We can do that because we're just adding them. So I'm going to write sine squared b plus cos squared b is equal to 1. Now watch what happens if I divide every term, by the cosine, cos squared b. I haven't changed the value of this equation at all because I've divided every term by the single value. Now, what do you notice about this term here? Well, that term is the same thing as tan squared b. So now we have tan squared b plus 1 is equal to 1 over cos squared b. And those are our different relationships.